Airbus may have just changed the autonomous helicopter game with the newly announced U145, an uncrewed evolution of the H145 that trades pilots for processors, a cockpit for sensors, and human workload for AI-driven flight control. It's designed as a mission-agnostic workhorse, hauling cargo, acting as a sensor node, or teaming with drones from ship decks or forward bases. But building a truly autonomous helicopter is far harder than it sounds, and Airbus isn't alone. To understand why companies are pushing so hard, from U145 to VSR700, S100, S300, and U-Hawk, we need to ask a deeper question. Why remove the pilots at all? At first glance, the idea sounds strange. Helicopters are among the most versatile machines ever created. They can hover over a battlefield, land almost anywhere, rescue casualties, deliver troops, and operate where fixed-wing aircraft simply cannot. But that versatility comes at a price. Flying a helicopter is exhausting. Unlike an airplane, which naturally wants to keep moving forward, a helicopter constantly fights gravity and instability. Every second requires adjustments to altitude, pitch, yaw, and power. Now imagine doing that while flying through mountains at night, avoiding enemy missiles, communicating with ground troops, and navigating electronic warfare. The workload becomes enormous, and the battlefield is becoming even more dangerous. Portable air defense missiles, anti-aircraft guns, drones, and electronic jamming mean that every minute spent over hostile territory increases the risk of losing both aircraft and crew. So, militaries began asking a simple question. If computers can perform many of these tasks, why keep risking pilots? The answer isn't to eliminate humans entirely. It's to eliminate unnecessary risk. The first example is Airbus's VSR700. Modern navies depend heavily on helicopters. They hunt submarines, locate enemy ships, conduct surveillance, and relay targeting information across entire fleets. But traditional helicopters face two major limitations. First, crews become fatigued. Second, operating from small ships is extremely demanding. The VSR700 tackles both problems. Built upon a proven helicopter architecture, it combines vertical takeoff capability with autonomous flight systems and long endurance. Instead of carrying a pilot, it carries sensors, electro-optical cameras, infrared systems, radar payloads, electronic surveillance equipment. The result is an aircraft capable of spending extended periods searching vast areas while the crew remains safely aboard the ship. Perhaps more importantly, Airbus isn't trying to replace naval helicopters overnight. Instead, the VSR700 is designed to work alongside them. Think of it as an advanced scout, moving ahead of the fleet, identifying threats, and providing commanders with information before human crews ever enter danger. It's less about replacing people and more about expanding what people can do. If the VSR700 is about endurance, the Schiebel S100 camcopter is about speed. Modern battlefields change by the minute. Waiting for a conventional aircraft may take too long. The S100 solves this by requiring almost no infrastructure. No runway, no catapult, no large support team. It simply lifts vertically into the air and begins collecting intelligence. Equipped with electro-optical cameras, infrared sensors, radar, and communication payloads, it can provide commanders with real-time situational awareness. That information becomes invaluable. Instead of sending soldiers into uncertainty, commanders can see exactly what's happening before committing forces. The platform's simplicity is its greatest strength. Minimal logistics and minimal crew but maximum flexibility. For many militaries, that combination makes it one of the most practical autonomous rotorcraft currently available. But surveillance alone doesn't win wars. Someone still has to deliver ammunition, transport supplies, move equipment and support troops. And that's where the Schiebel S300 enters the conversation. The philosophy changes dramatically. Rather than simply observing the battlefield, larger autonomous helicopters could sustain it. The S300 concept is designed around increased payload capacity and longer endurance. That means carrying heavier sensors, electronic warfare equipment, and logistical cargo. This addresses one of modern warfare's biggest challenges. Supplying frontline units is often more dangerous than fighting itself. Then comes perhaps the boldest concept of all, the S-70 Hawk. Unlike smaller autonomous helicopters, this platform begins with something already legendary, the Black Hawk. For decades, the Black Hawk has carried troops, evacuated casualties, transported cargo, and supported military operations worldwide. Lockheed Martin asked an obvious question. What if it could do all that without risking a crew? The result is an optionally piloted or autonomous helicopter capable of performing missions traditionally requiring human pilots. And because it's based on an existing platform, it inherits decades of proven engineering. Its advantages are enormous. Heavy cargo, medical evacuation, troop transport, resupply missions, operations during extreme weather, flights into contested zones. These are exactly the situations where commanders hesitate because losing pilots carries enormous consequences. Autonomy doesn't eliminate danger, it transfers it from people to machines. The biggest misconception about autonomous helicopters is that they're meant to replace traditional aviation. They aren't. The real revolution is cooperation. Imagine a future operation. A manned helicopter remains safely behind the front lines. Ahead of it, a VSR700 scans the coastline. An S100 identifies enemy positions. An S300 carries electronic warfare equipment to disrupt communications. Meanwhile, a U-Hawk delivers ammunition and evacuates casualties. Each aircraft performs a specialized task. Together, they function as a single coordinated system. This concept, known as manned-unmanned teaming, could dramatically increase the effectiveness of military aviation. Instead of one helicopter accomplishing one mission, an entire network shares information and distributes risk. The battlefield becomes interconnected. But here comes the big question. Can machines replace pilots? Of course, autonomy still has limits. Artificial intelligence struggles with unpredictable environments. Electronic warfare can disrupt communications. Dense civilian airspace creates challenges for autonomous navigation. And ethical questions remain. Who makes life and death decisions? The machine or the human operator? For now, most militaries favor keeping humans in command while allowing autonomous systems to handle repetitive and hazardous tasks. That balance offers the best of both worlds: human judgment, human endurance, human strategy, machine precision.